So at first you have to know what is dielectric. So dielectrics are that substances, okay, which cannot flow electric, but electrical effect can be seen here. For example, dielectric molecule, any dielectric substance having one molecule, it cannot take the electric and cannot pass the electric. But if we place this molecule in an electric field, this effect can be shown in dielectric molecules. That is, dielectrics are insulator. Okay. So dielectrics are basically insulator, but electrical effect can be seen in this. The dielectrics are basically two types. Number one, non-polar and polar. Okay, so dielectrics are two types, non-polar and polar. Okay, the non-polar dielectrics are that type of electric. The non-polar dielectrics are that type of dielectrics, this one, which has, so the non-polar dielectrics are that dielectrics having electric dipole moment is 0, but polar dielectric has electrical dipole having. So what happens? Two types of dielectrics. Number one is non-polar and another is polar. See here, what is given here? Dielectrics are non-conducting substances, meaning they don't have free charge carries. Like conductor, in conductor there are free electrons which carry the electric from one place to another. That is, they respond in electric field and carries the electric. So when placed in external electric field, dielectric do not conduct electricity. But if we place one dielectric in external electric field, it do not conduct electricity. That is, they don't have any free electrons. Okay. But what happened when placed in electric field? When placed in external electric field, dielectric do not conduct electricity, but they respond by realigning their molecule charges. That is, if we place dielectric in some electric field, they align themselves. Okay, they align themselves and respond by realigning their molecule charges. They polarize themselves. Okay, the next thing comes, what is polarization? So polarization is the alignment or displacement of charge within the dielectric when it is placed in an electric field. What happens? Imagine this is a molecule. In a molecule or in atom, there are electrons and protons. If we place this atom or molecule, the plus charge or the minus charge, that is electron and proton, do not shift, but the circular orbit becomes this. The electron comes to this and the protons are shifted to some extent to the direction of the electric field. So this is called polarization. The result in the formation of dipole. So when we place this, we can see the result of formation dipoles. The net effect is a reduction or not cancellation of the external field inside the dielectric. So as a net effect, we see the dielectric substances becomes polar. Okay. See here, non-polar molecules, what? Oxygen molecules. See, in an oxygen molecule, electrons are there. If we place the oxygen molecule in one electric field, the molecule becomes this. Molecule means the orbit becomes this. The electrons and the protons. Electrons goes towards the against the electric field and proton goes towards the electric field. And HCl, hydrochloric acid, is the polar molecule. If we place polar molecules in the electric field, then HCl, H is plus already, Cl is minus already. So HCl, in HCl this becomes this, Cl and H is already dipole. Okay, they align themselves. Now we will discuss about what are non-polar and polar dielectric substance and how they works. At first, you know what are non-polar dielectrics Example: oxygen, nitrogen, carbon dioxide. Pure hydrocarbons are non-polar, that is, they have no specific poles, that is positive or negative. They don't have any specific poles, so they are non-polar. Where they are used? In capacitor. Basically, you have to learn capacitor after some time. In capacitor, non-polar dielectrics are used as insulator in high voltage capacitor because they have low dielectric loss and high breakdown. What is this? You know, probably the transformer. In transformer, some oil is used. These oils are basically non-polar dielectric substances. So we have given here insulating fluid, non-polar liquids like transformer oils are used in transformer and circuit breaker. Okay. Next is why they are used. Dielectrics are used in capacitor because they increase capacitance. We will study now how dielectric increases capacitance of a capacitor. Okay. So prevent electrical conduction, they insulate the two plates to avoid short circuiting. Okay, increase the breakdown voltage, etc., allow for compact design, etc., etc. Mainly benefit of dielectrics in capacitor. How a dielectric works in capacitor? How works? When dielectric is placed between plates of capacitor, imagine this is a capacitor. When dielectrics are placed, here some dielectrics are placed, polarization happens. Some electric field comes here and polarization happens. So plus and minus in a molecule, when polar or non-polar molecules, when is kept in electrical field, they polarize themselves or align themselves. How? Towards the electric field, plus goes, and against the electric field, minus, negatives. So it is discussed here. The electric field from the capacitor causes the molecule in the dielectric to align positive towards negative plate and vice versa. Okay, positive towards negative place and vice versa. That is, this is the connection. So electric field is always from positive to negative. So positives are towards the negative plates and negatives are towards positive plates. This creates induced charges on the surface of the dielectric opposing the field from capacitor. So what happens? Opposing the field. Know this from this diagram. So this is dielectric. This is plus. These are plus and these are minus. At first, the field direction, outer field direction was this, but due to inner distribution of the charge, that is alignment, due to alignment, again another field is created in the capacitor, this. So outer field is if E0 and inner field is if E, imagine C, then the net effect of field will be E0 minus EC. Look at the diagram very carefully. Okay, this is plus, this one is plus, this one is minus, field from plus to minus, the minus, and these are the plus of dielectrics molecules. Now we will discuss about the formula. What is the formula? P equal to chi epsilon naught E. This one is chi. So how comes? For how polarization depends on field. How polarization depends. This is the what we have discussed. The dielectrics gets polarized. Then how depends this? For linear isotropic dielectric, where the response is uniform in all direction, experiment shows. You don't need to know what is given here. Just learn. Experiment show that P is directly proportional to E. Polarization is directly proportional to E. E increases, polarization increases. This means P is directly proportional to E. Stronger the field, stronger the polarization. So introducing susceptibility, chi. To convert this proportionality into equation, we introduce a constant of proportionality called electric susceptibility. This one, chi. But since electric field are also related to permittivity of the free space, so the relation becomes P is equal to chi epsilon naught E. Okay, E electric field, permittivity of the free space epsilon naught, and chi is the proportionality constant. Okay, and you just know the value also. Permittivity of the free space 8.85 10 to the power minus 12 coulomb square per Newton per meter square. Okay, polarization unit and electric susceptibility is a unitless, depends on only material.